Hey guys, earlier this week we had a live stream question and answer video for the Flying Like Iron Man project. In this video we've cut down that live stream to just the best questions and answers. And we've also compiled a huge list of the questions and answers on our website. There's a link in the description below. We've also launched the GoFundMe campaign, so if you're interested in supporting the project or even just learning more about the project, check out that link in the description too. Enjoy! Alright, hey guys! So for this live stream we're going to do a question and answer period on the Flying Like Iron Man project. So we've prepared a few questions that we wanted to answer, and then we'll be taking questions from you guys from the chat window. To start off, we want to give you a bit of a background about why we're even doing this project. And ever since we started playing with different technologies, we've always kind of wanted to try flying, because who doesn't want to fly? And originally we were thinking about just building a giant octocopter, like a quadcopter but with 8 fans. And while this would have been possible to do, they would have had to been huge. Basically the entire vehicle would be about the size of a helicopter, which is a bit overkill. So when we learned about electric ducted fans, we thought maybe there would be a way to actually make a smaller version that would actually allow us to fly. And what you guys might not know is Robert Downey Jr. actually shared my original exoskeleton project on Facebook. And he happened to make the comment, "Make a flying version and I'm sold." So we kind of took that as a challenge to actually make a working flying Iron Man suit. As you can see, we've actually launched our GoFundMe campaign now to help raise money for the project. So if you guys have time, take a look at that. The link is in the description underneath the video. But let's get back to the question. For everyone who didn't know, that is Ian. He's my business partner. He helps run the YouTube channel with me and helps design all the projects. The number one question that we all know you guys are waiting for: did I vote for Trump? And the answer is no, I didn't vote for anyone because I'm Canadian. Another question that we've received quite a bit is, the current system can lift about 32 kilograms or around 60 pounds. Which means, hypothetically, if we strapped a kid into it, they could fly. And while I'm sure we get plenty of volunteers, getting a kid to fly is kind of cheating, and it's also not very safe, because I don't want to accidentally kill someone testing my project. If anyone's going to die, it should be me. Next up, there's a lot of people wondering, how are we actually going to be able to fly and be stable with a system with basically just fans attached to my limbs? Obviously, that's either going to take a heck of a lot of muscle control, or there's going to be some intelligence in the stabilization. The jetpack, which we haven't really talked about much in the videos yet, will actually look kind of like a hexacopter, which is a type of drone. And basically that, right here, is a rough mock-up of what it might look like.
Just a mock-up, so ignore the supports running into his shoulder. We haven't designed the harness yet.
One of the next questions that we received the most on the YouTube channel is questions about the power system and how we're going to make it work. A lot of people suggested that while we're testing this, why don't we have a tethered power system where we basically plug into the wall to power the motors. The final project will be around 100 to 150 kilowatts. That's the same as about 3 to 4 houses on your street. So the short answer is, no, we really can't do that. There's some other people suggesting, can we use solar panels? And again, that's a hard no, because solar panels aren't that efficient. My house's roof is covered in solar panels. It's about 100 square meters of solar panels. And on a good sunny day, it might produce 6 kilowatts of power, which is barely enough to power just one of the EDFs. The other big problem with running a tether to the flight system is pushing 150 kilowatts through wire is crazy. The cord would have to be huge. It would be probably a couple inches in diameter. In fact, it's actually going to be heavier than the batteries themselves. The only way we could do a tethered power system is if we hang the power system behind me and have the cable droop down above the stunt wire system to me. So we might try doing something like that. But the other big problem with having a long cable is the longer your wire is, the more resistance there is, which means you're losing power that you can be using to fly. So really the best option is having the batteries on me.
This wire, which is about the size of my finger, can safely handle maybe 1,000 amps. So it's going to be more, a tethered system would need to be more than twice the size of this. This is like solid copper, so it's pretty heavy. So imagine twice the size of this, then you need two for positive and negative, and then you need to have a long length of it so that it reaches it.
How long are we going to be able to fly for if we use lithium polymer batteries? And our rough calculations say we should be able to fly for about 1 to 2 minutes. I saw a question up a while ago asking why don't we use a gas engine? And there's a few reasons for that. Gas engines are too big, and they're a lot harder to control if you're using a multi-prop system, because you can't get as accurate speed control as you can from electric. The other comparison to note is this is one of the electric motors we're using. So this is about 5 or 6 kilowatts, which is the equivalent of about 8 horsepower. Anyone who's ever used a go-kart or a lawnmower knows that an 8 horsepower gasoline engine is like this big. Considering that we need almost 20 of these, you're just not going to be able to do that with a gas engine. If you did, you'd just be building a helicopter, and that's kind of not the point. Another point about the active cooling. Luckily, we live in Canada, which means it's going to be winter soon. So if we test the system outside, we'll have a bit of a temperature gradient that we can work with that will make the system last a bit longer. Another major question that people have pointed out is, this has been done before. There are other projects out there that allow you to fly. One of the most famous ones at the moment is called the Zavada Airboard, or Flyboard, and it is amazing. But what you have to remember is the Flyboard is a $250,000 prototype made by a company with years and years of engineering behind it. I'm pretty sure one of the jet turbines they use costs $50,000 each. Another few people have been asking about our current sponsorship with Hobby King. Basically, Hobby King has been providing a bunch of parts to us for free. They haven't been paying for the project or financially supporting us, but they've been giving us as many parts as we need that we can use for the project. Unfortunately, these are the largest EDFs that they sell, and if we were to use those, we'd need over 20 of them. Alright, so we're going to start answering a few questions. If you guys want to ask a question, we're getting spammed in the chat room and we can't really keep track of everything. So there's a link to Discord, which is another chat app, where you can post your questions and we'll be able to answer them from there. You do need an account for Discord, but it is super quick to sign up. Literally, you type in your email address and you've logged in. Okay, so here's one question. You should set up the system to run off a car battery on your back. What do you think? Car batteries aren't that good. Lithium polymer is typically around 3 times as efficient as a car battery. So for example, those little yellow batteries that we have,
We don't have any up here.
about 4 of those is equivalent to 1 full-size car battery. So it's a much superior battery technology. If we were trying to fly with lead-acid car batteries, I don't think you could. They'd just be far too heavy. There's been a few people asking questions about the size of the EDFs. This has been answered multiple times in our videos, and in any of the Ironman flight update videos, if you click expand description below the video, you'll see the specifications and links to all the parts we used. The ideal suit should be self-charging from Traffic Dreamer. That would be ideal, but just is pretty much impossible because 150 kilowatts is an insane amount of power, and there's not really anything you could do to recharge that efficiently or by itself. So the other option, as opposed to buying those really expensive EDFs, is potentially making our own EDFs, which, while is possible, is unlikely it's going to work, but we're going to try anyways. Now, the problem is the plastic isn't the greatest. Can you squeeze it? As you can see, it's very flexible, as opposed to one of the EDFs from Hobby King, which is very rigid. You can't bend this at all. So there's a bit of a concern, will we actually be able to put that much of a weight on a 3D printed part like that? If it is possible to build our own EDFs, that would be awesome. The motors will still be pretty expensive because we can't build those, and the motors we need would still probably cost around $1,500 to $2,000 each. A few people have been asking, are we going to build a suit? Maybe in the future, but it's going to be really hard to fly just by itself, let alone adding something heavy like a suit on top. So this is flying like Iron Man. This isn't building an Iron Man suit. Not yet, anyways. Andrew Gibson asked, when are we going to do the co-op with Z-Not Alpha Productions? Have you not been watching my videos? He was in the past 3 videos. Hey Eli, how's the editing coming?
James, this is not okay. I can't even edit properly with my left hand.
You gotta edit a bit faster than that.
James, it's starting to hurt. I'm starting to bleed. You can see it.
Okay, a few other people are asking, why not use rockets? If you've watched this entire series, you'd know why. Rockets just won't work. They only last for a few seconds, so really it's a rocket boost, which is pretty much pointless, not to mention it's super expensive. Each of those rockets cost about $30 each. So to fly, you'd have to blast off a ton of the rockets, all in quick succession, and it just is pointless, because with the system we're designing right now with EDFs, we can recharge the batteries and we can fly it again and again and again. So while the upfront cost of building it with EDFs is going to be really high, we're actually going to be able to reuse this project. It's not going to be one test, one video, and then we're done. Alright, we'll take a few more questions here. Cole Dowrick says, you are planning on spending way more money than you need. Try to actually plan it out. You need under $5,000 for a fully done suit. Well, Cole, if you can build a flying suit for $5,000, please do that and get back to me as soon as possible. Owen Langford asks, where did we get that car to destroy with Reinhardt's hammer? It was actually a friend's car, which was off to the scrapyard anyways, and we paid him $100 to smash it up before he took it to the scrapyard. Yes, it still ran, but the frame was rusted out, and it would have cost thousands of dollars to repair enough to actually get it safety certified to be on the road, which is way more than a 15-year-old Sunfire is worth. So a lot of people were like, oh, why didn't you just sell the car for the Iron Man project? We couldn't have sold the car. It was literally worthless. Some people saying use ion thrusters. Ion thrusters are a really cool technology, but they're tiny. There's no way to manufacture them on a large scale to actually be able to fly. A few people have also asked, why not use pulse jets? Colin Furse has used pulse jets for all kinds of vehicles, and they're friggin' awesome. When I visited him last month, he actually showed me how to start a pulse jet engine, which is sweet. But the problem is, pulse jets are not very efficient at all. In fact, their thrust-to-weight ratio is almost 1-to-1. So basically what that means is the pulse jet weighs as much as the thrust it puts out, which means you really can't use it for any kind of system if you're planning on flying. We've seen quite a few times from people who actually know some stuff about EDFs, they've asked, why don't we make thrust tubes? So when an EDF is mounted in a plane, they actually have a tube coming off the back. And what this does is actually increase the thrust output of the EDF by up to 20%, which is awesome. So the question is, why aren't we doing that? And the answer is actually pretty simple. A thrust tube only increases your dynamic thrust if you're moving already. So for a plane flying in the sky, the change in airspeed from outside the plane and going in to the EDF makes a huge difference. If you add a thrust tube in a static scenario where you're just trying to float, it actually reduces the thrust. Kip K can help you make the motor stronger with solar panel. No, Kip K cannot do that. Question, how high do you want to go after this project is done? Basically only as high as I feel safe flying, because if we have any problems and I fall, well, I'm falling, breaking my legs, and probably dying. Someone also asked, could you use compressed air or some sort of CO2? No, you couldn't. There's just not enough energy density in pressurizing gases in order to fly. In fact, if you compress, say, CO2 to about 5,000 psi, like a scuba diving tank, it'll have about the same energy density as a lithium battery, which means it's easier to just use a lithium battery because you don't have a heavy tank to hold that much CO2. Question from Adam Ellers. You said EDFs can get really hot while staying still. Can you generate power from that heat? Hypothetically you could, but any kind of system that could harness that heat would weigh too much versus the amount of energy you could collect from it. So it's kind of a catch-22. You wouldn't be able to get enough power out of it to make it worthwhile. Alright, so what are the next steps for this project? Well, number one, if you guys want to really help out the project, you guys can click on that link below and check out the GoFundMe campaign, because we're not going to be able to afford the giant EDFs by ourselves. And if we are, that means this project is going to take probably a few years to complete. So if you guys want to see it happen sooner, check out the GoFundMe. But we do have quite a bit of video content planned before we get to that stage. The next video we'll be putting out is a not-so-safe safety test video where we'll be showing exploding batteries, exploding some EDFs, and a few other safety tests to see how dangerous this is and what we need to do to protect me as the pilot while I'm flying. So check out that GoFundMe campaign below. The link is in the description. Even if you don't want to support the project, it contains a lot of info, and a lot of your questions have been answered on that GoFundMe page, because we're giving some information about how the project is going to work. Another common question that has been asked recently is, why don't we use jet engines? Because you can buy model aircraft jet engines used for RC, and they're not too big, fairly similar in size to the EDF. They're also very expensive. I believe one that would put out about 50 pounds of thrust would cost us about $3,000 to $4,000. So it's around the same price range as the EDF. Yes, it will last longer because you can use fuel, and fuel has a higher energy density than lithium-ion batteries, but the other thing you have to worry about then is jet engines rotate at about 110,000 RPM, which makes them a bit unsafe. And two, it is a very hot idea, because basically the exhaust coming out of a jet engine is around 700 to 800 Celsius, which I believe is almost enough to melt. What's the material that would melt? A lot of stuff, including flesh and bone. Make your own jet engine. We can't make our own jet engine. Again, they're extremely complex machines that we just don't have the resources or equipment to build. There's a reason they're super expensive. SDF asks, why don't you just buy a helicopter instead of building one? Well, that's because we're not building a helicopter. What would be the ins and outs of magnetic levitation? Basically, magnetic levitation is pretty much not possible. You could do it, but you basically need a special floor, which would cost thousands of dollars, and you'd be able to float maybe an inch. So not very exciting. If you're interested in learning more about magnetic levitation, just look up the Kendo hoverboard, as it uses magnetic levitation, and it's really cool, but you can't use it anywhere but the special floor. A few people have asked what the frame will be comprised of. It will be mostly made of 3D printed parts, plus potentially carbon fiber wrap to increase its strength. Do you have any other upcoming projects besides this one that you're really excited about? And yes, I do. It's the grappling hook gun project. We're making a Batman grappling hook gun, and it is awesome. We've already tested it a bunch, but we're not done the video yet. If you successfully complete this project at a reasonable price, will you make your finished product commercially available and mass produce them? Very unlikely. Again, because battery technology just isn't there yet. Any finished suit's only going to have a run time of about a minute or two, which really isn't enough time for any commercial application. So probably not, but who knows. Someone asked, can you mount magnets on the inside of EDFs to make magnetic thrust and infinite power? No.
Thanks for watching the stream. If you guys have more questions, don't forget to join our private Discord chat room. There's a link in the description below. You can talk with us, the Hacksmith team, and other people interested in the project.